Hello students, welcome back. Students, in this video, we are going to discuss 3 questions from shift 2 of 22nd Jan. First question will be from trigonometry, second from probability, and third from permutations and combinations. So let's start. Students, question is, if 2x square plus cos theta times x minus 1 is equal to 0, where theta belongs to 0, 2 pi closed, has roots alpha and beta, the maximum and minimum value of alpha to the power 4 plus beta to the power 4 is m and small m, then find 16 times capital M plus small m, right? So in question it is given that alpha and beta are the roots of this given equation, this quadratic equation, right? So from here I can write alpha plus beta is minus cos theta by 2 and alpha beta is minus 1 by 2. Okay, now we have done so many things in symmetric functions of roots. In the topic symmetric functions of root, we have seen alpha square plus beta square in terms of alpha beta and alpha beta, alpha and beta, alpha cube plus beta cube, alpha to the power 4 plus beta to the power 4, and so on. So many things we have seen. So similarly, I can again write alpha to the power 4 plus beta to the power 4 in terms of alpha and beta as alpha square plus beta square whole square minus 2 alpha square beta square, right? And also alpha square plus beta square is nothing but alpha plus beta whole square minus 2 alpha beta whole square minus 2 alpha beta whole square. Now I can put alpha plus beta and alpha beta because I have already these things. So alpha plus beta is nothing but minus cos theta by 2 whole square minus 2. Alpha beta is minus half. So this is minus half whole square minus 2 times minus half whole square, right? Now this thing will become cos square theta by 4 plus 1 whole square minus 2 into 1 by 4, that is 1 by minus 1 by 2, right? Now this is alpha to the power 4 plus beta to the power 4. Now this whole square can have maximum value 1 and minimum value depends on cos square theta. If cos square we all know very well, now we can find its maximum and minimum in the following ways. Cos square theta is lying between 0 to 1 closed, so cos square theta by 4 may be lying between 0 and 1 by 4 closed, and cos square theta by 4 plus 1 can lie between 1 to 5 by 4, right? And whole square cos square theta by 4 plus 1 whole square will lie between 1 to 25 by 16, and if I subtract minus half from this, so what will I get? 1 by 2 in left and 25 by 16 minus half in right. So this will be 25 minus 8 is 17 by 16. So This is nothing but 17 by 16, which is capital M and it is small m, right? So 16 times capital M plus a small m becomes 16 times 17 by 16 plus 1 by 2. Okay, so 16 times 17 plus 8 by 16 will be 25. So which is 25 is the required value. Okay, so let's come to next question. Question is from probability. So students, question is, let A and B are two events such that P of A intersection B is 1 by 10 and P of A slash B, comma P of B slash A are roots of the equation 2x square minus 7x plus 1 is equal to 0. Then P of A complement union B complement upon P of A complement intersection B complement is equal to. So students, P of A slash B, what does it mean? P of A slash B is nothing but probability of A when B has happened, right? It is read as like this. And P of B slash A, probability of B when A has happened, right? Now it is given that roots of 12x square minus 7x plus 1 is equal to 0 are P of A by B and P of B by A, right? So sum of roots, that is P of A by B plus P of B by A, is 12 by 7. Okay, and also P of A by B into P of B by A is 1 by 12. Sorry, it is not 12 by 7, it is 7 by 12. My mistake, right? So now P of A by B is P of A intersection B by PB plus P of B by A is P of A intersection B by PA, which is 7 by 12. Okay, now if I take P of A intersection B as common, then it will be P of A 1 by P of A plus 1 by P of B, okay, which is 7 by 12. Now as it is given that P of A intersection B is 1 by 10, so 1 by PA plus 1 by PB will become 7 into 10 by 12, right? Okay, or P of A plus P of B by PA into PB will become 35 by 6. Say this is 1, equation 1. Now from product, from product of roots, what I can say, P of A intersection B by PB into P of A intersection B by PA is equal to 1 by 12, right? So P of A into P of B will become 12 into 1 by 10 whole square, right? So this is 2. If I put the value of P of A into P of B in 1, then what will I get? P of A plus P of B will be 35 by 6 into 12 into 1 by 100, right? So this will be 6 to the 12, 70 by 100, or 14 5s are 70 and 20 5s are 100, so which is 7 by 10, right? So P of A plus P of B is 7 by 10. Now what is required? What is required? We need to find P of A complement union B complement upon P of A complement intersection B complement, right? But P of A complement union B complement is nothing but P of A intersection B whole complement, okay, using De Morgan's law. And similarly, P of A complement intersection P of A union B whole complement, again by using De Morgan's law. So P of A intersection B whole complement is 1 minus P of A intersection B. As P of A intersection B is given, P of A intersection B is given, so I can find P of A intersection B complement, which is 1 minus 1 by 10 is 9 by 10. Also, using P of A union B, which is P of A plus P of B minus P of A intersection B. P of A plus P of B is 7 by 10. We have found this thing, right? So 7 by 6 by 10. So therefore P of A union B whole complement can be 1 minus P of A union B, which is 1 minus 6 by 10 is 4 by 10, right? So therefore P of A complement union B complement upon P of A complement intersection B complement is what? P of A intersection B whole complement, and which is 9 by 10 on P of A complement intersection B complement, and which is P of A union B whole complement, which is 4 by 10. So whole answer is 9 by 4. So which answer is 9 by 4, and which is required answer, right? Okay. Now, now let's move to next question, which is from permutations and combinations. Students, question is, 4 boys and 3 girls are to be seated in a row such that all girls sit together and 2 particular boys, say B1 and B2, are not adjacent to each other. Then the number of ways in which the arrangement can be done. See students, restriction is imposed on boys and on 2 particular boys, B1 and B2, and other 2 boys are free of restriction. And there is one restriction on girls also, that all girls should be together, right? So if I use the concept of string method, so with a string I can tie G1, G2 and G3 so that all girls are together, and say B3 and B4 are free from restrictions. So there are three units. One unit is having G1, G2, G3, and second and third units are boy 3 and boy 4. Now these three units can be arranged in 3 factorial ways. So number of ways are 3 factorial. But in these 3 factorial ways, 3 girls can be arranged in between them in among themselves also in 3 factorial ways. So into 3 factorial ways by fundamental principle of counting. And also we have to arrange 2 boys also so that they are never adjacent. So if among these 3 units we are creating 4 gaps to place these 2 boys so that they are never adjacent. So in how many ways this can be done? 4C2 into 4C2 into 2 factorial ways. So by using fundamental principle of counting, total number of ways will be 3 factorial into 3 factorial into 4C2 into 2 factorial, right? So this 4C2 represents what? Selection of 2 gaps out of 4, right? And this 2 factorial represents placing B1 and B2 in 2 places, right? And this 3 factorial is arrangement of 3 units in a row, and this 3 factorial represents arrangement of 3 girls among themselves, right? So how many ways it will become? 3 factorial 6, 3 factorial 6, 4C2 is 6 and 2. 6 is a 36, 6 is a 216, 216 into 2, which is 432. 432 must be the correct answer. Okay. So students, let's meet in next video. Till then, bye bye. Take care.